Uh, I hope you hear me well. Good. Thanks for coming. Here I'll be talking about a topic that I hope none of you have to face, but since you came here, you probably have the challenge or something related to it. To you, if you have some Java EE solutions still running out there in some projects, and you want to upgrade them, to modernize them, this is the session for you. So I'm going to ask you to first to scan the Slido QR code if you want. It's for asking me questions. So if you want to ask me questions later, you can scan it already and go to the place and then just type in the question. I will have one or two more slides later, so you can still get the chance to scan it if you haven't done that already. So we're in Cinema 5, but I think you know it. A bit about me. I'm a Java champion. It's nothing that I would be really awarded for, but some people thought that they like me enough to offer me this title. But what I value more is that I'm a Jakarta EE committer. I'm heavily involved in several specifications in the Jakarta EE specification. I'm also a committer to GlassFish, which is an implementation of Jakarta EE. And besides that, I'm also a Java user group lead in Prague, in Czech Republic. And I run a company together with two other co-founders, which is called Omnifish. And we are, again, heavily into Jakarta EE and GlassFish. But coming back to the topic, I got inspired by this topic when I realized, based on surveys, based on talking to other people, that there are still a lot of people, a lot of companies that use old Java EE servers, or servers that, or older versions of servers that still run Java EE. Java EE 8 is the latest version of the thing called Java EE, because as most of you hopefully know, Java EE got transferred under the Eclipse Foundation and is now called Jakarta EE, but this is still Java EE 8, the last version before it got transferred. And with this, I realized these are some numbers from some survey in 2023, so it's pretty old already, but it's hard to find the data and from different surveys. Almost 50% people or companies use WebLogic and WebSphere, which are servers which are kind of special compared to others. They don't support anything else than Java EE 8. There's no way to upgrade their version to run on something newer, to have Jakarta EE. So people are basically stuck with that. And I talked to some people like this. They were not happy. There were some promises that new versions of, let's say, WebLogic will support Jakarta EE 9 or 10, but nothing happened. But what is even more surprising, out of the other ones in green, you have multiple options. Still, most of the people, even if they have the option to upgrade, or at least in 2023, I hope the numbers are better now. In 2023, most of them, 3/4, were still running on a version that supported either Java EE 7 or Java EE 8, but no new version of Jakarta EE. So you see that at that time, a lot of people were just before the decision what to do, either upgrade or migrate or what to do to maintain the project. But the question was how. So I knew already a lot of answers to this question because I'm involved in Jakarta EE, but I thought that people might be interested to know something that they probably don't know, but I know. What are the options? And first thing, I thought like SpringBoot is really popular. It's not Jakarta EE, but a lot of people told me like they think about moving to Spring because application servers are no longer popular. It's not easy to work with them, and that's true. Especially if we talk about the old servers, it's not possible to upgrade them to anything newer. But with Spring Boot, there is a catch. on one side, it's very popular. It supports a lot of things. It's fairly easy to work with. It has development mode and Docker cloud functions, a lot of things in the ecosystems. So I would put it, in other words, it's easy to start with it. It's easy to start building new services, new applications. But if you realize what that means, start means either you start from scratch, which almost nobody is there, or you rewrite existing code, because SpringBoot is mostly incompatible with Java EE. It supports some of the APIs. I'll mention them here. Supports out of the box APIs like JPA, Java Persistence, or messaging, JMS. It can support JAX-RS, JSF, although it prefers that you use its own Spring MVC and templates like TimeLeaf or other solutions rather than JSF. And it doesn't support some other things. So if you already have EJBs or code related to CDI or Jakarta security or some other Jakarta stuff there, it's not so easy to port it to Spring Boot because you have to rewrite these. So in the end, what I saw in real world, it's not only that I warn you about this, but the risk is real, is that you start building new things in Spring Boot. You have to either rewrite or you just write new services in Spring Boot. But it takes still a long time until you get rid of the original Java EE code. And if you do this, you still have the old server, you still have to maintain it. And most often you will have to add some new features or add some fixes. So now you have Spring Boot services, which are nice, but you didn't get rid of the Java EE server. So only new code is easy to do, but you still have to know and remember Java EE. Now Spring Boot is a bit of different API, so you need to learn both to be able to maintain this system. And here is an example of a real-life customer I was working with, and I'm still working with, and I see there is still a pain. To be honest, most of the pain is from the monolith and from the application server or application running on the application server. I don't think that the application server itself is a problem. It's more like the application is huge, is not designed to be modular, and is not easy to maintain. And they started 6 years ago with moving from this monolith. They decided to go with Spring Boot. So everything they write as a new service, they use Spring Boot, which they like, but they still have to maintain the monolith. And sometimes they have to duplicate the code because they can do it in a service, but sometimes they also still need it in the monolith for some cases. So really they have to maintain two different code bases. And yeah, it's hard to predict when it will happen that they will completely move away from monolith and rewrite everything to Spring Boot or something new. Now they have an effort to extract the front end to some JavaScript part and only have REST services. So hopefully somehow they will converge to the ideal solution. So this is a diagram of it. You see, you would like to have, or they would like to have, nice microservice architecture, but in reality, only the right part is about it, the 30% code after 6 years, and still 60-70% of the code is on the left, and it's on a microservice. It's still the big one, monolith, and no one can tell when it's going to go away. So I think I edit the slide pretty soon, but if you already have questions, or you still haven't captured the QR code, we have another chance now. Another case was I talked to a person right after my similar presentation like this one. I showed all the ways how to upgrade, and he came to me and said, yeah, this is basically our situation now. Half a year ago, we decided we want to migrate to SpringBoot from monolith running on WildFire, and we're halfway through, and it's been already. It wasn't 6 months ago. It was planned for 6 months, so it was already 12 months ago. But they thought that in 6 months they will be done with it. After 12 months, they haven't finished. So you see, it's real situations when it's risky to start with something that you think will be fast, but in reality it takes much longer. So it makes sense to start with something that is even less challenging, maybe not ideal solution, but easier to achieve, because in reality it will for sure take twice or 3 times longer, or even longer than that, because we as developers tend to underestimate the complexity and how long things take. So coming back to the situation, we have a Java EE code running on a Java EE server. In the worst case, it's one of those that we cannot easily upgrade. So my first advice would be just upgrade the server. Maybe it's already better. The new version of the server is better and lightweight, because companies work on it to improve their applications, or at least those that mean it seriously. Companies like Oracle are also nice, because they probably don't care so much about WebLogic, but they heavily invest into other solutions like Helidon. So their solution is like, okay, you learn WebLogic, but we provide you a Helidon, which is like smaller microservice framework, also supported by our team, and you can migrate to microservices running on Helidon. So that's one answer. But if you want to get rid of this server, it's not easy to rewrite everything to Helidon. It's easier than to rewrite to Spring Boot, but yeah, it has to be done step by step. So the best and easiest solution usually is to upgrade the server, if you can. If not, you have still plenty of options to migrate to some other server, which has a modern version. So let's say again WebLogic, but the same applies to WebSphere. If still anybody uses WebSphere, it's the easiest thing is to migrate to some other server, Pyra, WildFire, GlassFish, whichever is easiest. Then it still takes some time to explore which of them is the best to migrate to, which is more close to what we have now, what we will be missing in the other server that we have in the current server. But it also depends on how you build your application. If you depend on Java EE, and you can easily replace the other stuff that is specific to the server, then you can quite easily migrate to any other server. That's the promise and real promise of Java EE and now Jakarta EE, because I saw a lot of companies that did it. They replaced one server with the other. For some, it took 3 weeks. To some, it took 1 year to analyze all the things. But it was doable. It's only different based on the application and what you need for the application to run. And then you can get to some servers that are really modern, and you can be happy with them for a long time without thinking about some other thing. If you want, you can write new code in Spring Boot, but you'll be much more happy with what you have now compared to what you had with Java EE servers back then. So as an alternative to WebLogic and WebSphere, you can have a look at a list of servers that support Jakarta EE10. There's a Jakarta EE website, and Jakarta EE, I will remind again, is a continuation of Java EE, but now under Eclipse Foundation, and its development is more open than it was before, where it was mostly governed and also kind of restricted by Oracle. Now even the testing kit of Jakarta EE is open. You can see all the tests and the source code of the tests that are run against each implementation that certifies as compatible with Jakarta EE. So everything is in the open in the Eclipse Foundation, and we thank Eclipse Foundation for that as a company behind one of the implementations. So besides GlassFish that me and my company are heavily involved with. There's WildFi, Pyra, OpenLiberty, all of them are open source. All of them you can start using for free, look into how they work. And all of them, except maybe besides WildFi, they are directly supported by some commercial companies. So if you have some troubles, there is somebody you can contact. There is also community that can help you with any questions. And I mentioned WildFi. The thing is, there's a commercial version called JBoss. So yeah, even for that you have an option to get support, but I think you have to migrate to JBoss, which is almost one-to-one to WildFi. I'm going to use GlassFish as an example of one of these servers, but it doesn't mean that GlassFish is better or worse or whatever. I think it's very good server, and it's worth to look at the current status of GlassFish. The history of GlassFish wasn't always pleasant. For some time it was kind of abandoned after Oracle dropped support and then stopped development on GlassFish, so it was really getting only the necessary stuff to pass the Java EE certification and then Jakarta EE certification. But in recent years, since GlassFish 7 and Jakarta EE10, it's now production ready. It was a lot of fixes, a lot of problems were fixed, and it's modernized to run on the recent Java version, and all the recent stuff is there. There's Docker support. So this is in a nutshell what is with GlassFish server. Startup time was optimized, so I think you'll be pretty happy to see what it is capable of and how it compares to the old servers, or maybe what you think about application servers. I would say it's now more like a modern Jakarta EE platform than the full bloated application servers that everybody thinks about when somebody mentions application servers. So it's supported by IDEs, it has Docker support, but it has also some drawbacks. It doesn't support native builds with raw via, like which application server does that? For that, you need to have some other alternative in Jakarta EE space. It's not so good in cloud functions because it by default or automatically it starts HTTP listener, so it's good for even microservices, but not cloud functions, because cloud functions just invoke a method. You don't need an HTTP listener. It's the cloud that is the HTTP listener, and it directly goes, basically by reflection, it invokes a method. So for that, GlassFish is not useful. What is good about GlassFish is also provides GlassFish embedded version, which is an executable jar file. You can start, you don't need to install the full server, configure it. You just pass a properties file to it, an application you want to run, and run it from command line. You can also embed it into your application, so you can start it with the code. You can customize how it's configured based on some logic. And you can also run it with the same Docker container, which is what is kind of interesting, that it can be distributed separately as a jar file, but the GlassFish installation itself contains a jar file which you can execute in the same way. So there is one single Docker image for both. With one single Docker image, you can either start by default the GlassFish server and treat it as a server, or with one command line switch, you can start the container as embedded GlassFish, and it will behave as a runnable jar that gets application in some directory and reads configuration from properties file in that directory and like that. But again, it's not useful for native build and cloud functions, because it's basically GlassFish server just optimized for running microservices, smaller applications. It can deploy multiple applications, but it's not the best use case. It's optimized to run one application. By default, it deploys it on the empty context root, so it's quite natural how it works. I can actually show you. So with GlassFish server and GlassFish embedded, naturally you can run any WAR file, and even GlassFish embedded supports the whole Jakarta EE. Maybe not or almost whole. It supports even remote EJBs. It doesn't have an embedded message broker, so if you try to send a JMS message, there's nothing to pick up the message. But it can be added as a resource adapter. And it doesn't have administration console or anything like that, what you imagine with an application server that you run it and then you deploy an application and you monitor things. It's not there because if you run from command line, you just want to run a microservice in a container and just keep it simple. So if I have some REST service, no, not this one. This one. This is a plain Jakarta REST resource. It's bound to this path, and there are methods. The methods is bound to a subpath. So this service can be started with GlassFish. I will run it in this way as I described. So you can see it better. I don't know, probably like this is better. So I can type Java jar, and I have the path to the GlassFish jar here. It's just the location of the jar. It goes to GlassFish embedded all jar. So I can run it from jar instead of installing and running the application server, and then I have the application here somewhere built. Typo, sorry for that. And it starts much faster than the server. Oh, I think I have the server running somewhere. So I need to stop it. Or let me do something better. I can just specify the port so that it doesn't clash with the running server. A lot of things can be specified on as an argument, or I can create a properties file and specify it there. And it automatically prints the path where it's listening to. Nothing happens if I open it because it's a REST service. I would have to specify some arguments to it, otherwise it will give me an error. But it's running here plus the path to the REST resource and some arguments. It starts on my computer in around 3 seconds compared to the application server, the GlassFish server, which starts about in double time, 6 or 7 seconds. So if you need faster startup time and you still need a lot of the whole power of Jakarta EE, that's also an option. And the nice thing is you can still keep the same code. If you want, you can just take the code and like extract it from the monolith, run it with GlassFish embedded. If you want to extract it in the service, you don't need to introduce SpringBoot. You can. I don't discourage you from that. It may have some other options for you if you really want to go this way and benefit from the SpringBoot ecosystem. But since now Jakarta EE is actively maintained and evolved again, you can benefit also from that, and you can keep using Jakarta EE as with the monolith and also with microservices if you run them on GlassFish embedded. Because if I do the same thing, just as an example to demonstrate what is the differences, although you probably know if you already work with SpringBoot, where do I have this? This one? No, I think I failed to build it. Okay, I think it's here. Just need to make it bigger. So this is the comparison of code. I think on the left, yeah. On the right, it's my code in Jakarta EE. And on the left, it's the same resource, but with Spring Boot annotations. And here we're lucky, because Spring annotations are just almost one-to-one mapping to Jakarta EE, and the API is very similar. We just replace path with request mapping, then there is this validated, so with Jakarta EE we don't need that, that's out of the box. if you have valid annotations for validations. Here you use SpringBoot auto-wired. In Jakarta EE is inject. So very similar. And here you have get and path is two different annotations. Well, in Spring it's one annotation with everything, and produces is third one. So in Jakarta EE you have three different annotations. In SpringBoot is one with just attributes. But in reality it's very similar. And here we're even more lucky because the validation specification is supported also by SpringBoot. So the validation annotations to set that we want these arguments to have certain format, we validate the arguments to the service. The API is the same. In worst case, in some other cases, like maybe JSF can be replaced. If you already have EJBs in the application, then you have to somehow rewrite them, probably to some components or services in Spring Boot, and then you have to find the mappings. For some things it's easier to map, so for some things it's harder. Currently I heard that AI can help quite well when you need to migrate stuff. I think Open Rewrite may also help, which is a tool that allows you to transform code based on some rules. If there is an already existing recipe, I don't know if there is, but maybe there is a recipe to take Jakarta EE code and migrate it to Spring Boot code. But still, it's not so straightforward. Much more straightforward is to just copy the code and run it with some Jakarta EE runtime that suits your needs. And one of them, which I showed you, is GlassFish embedded, which allows you to run just a small microservice fast without any real changes to the application or code. Another example. Where do I have this presentation? Yeah. Okay, I'll come back to this later. So another example of how flexible Jakarta EE is that there are other runtimes which are no longer application servers. They don't support deploying applications on it. They are basically frameworks, but they still support Jakarta EE APIs. I think none of them supports all Jakarta EE APIs, but they support some of them. And it's only different to how much extend, and then they provide their own APIs. Usually it's a runnable jar or something close to it, so you build your application and you can directly run from command line the end result. And they are optimized for fast startup time, low memory footprint. Most of them even support GraalVM native compilation, so you can compile them to binary if you want to have extremely startup times. And one example is Quarkus, which really has fast startup time even without native compilation, compared to GlassFish server, which starts with a simple application. It starts in 7 seconds. Embedded GlassFish starts in 3 seconds. Quarkus starts in 1 second. So you can see the differences, and has low memory footprint. And I'm not going to list all or enumerate all the benefits, but first I want to pinpoint one thing, and I want to show you an example of that code with a Quarkus. And if you look closer, it's the same thing as we had before with Java EE. I can compare Quarkus code. Where's this one? Yeah, Quarkus service, and the one that I run with GlassFish. Almost the same. It's just Quarkus doesn't support EJBs, so I had to remove this annotation, and that's it. The rest is the same. Quarkus, what it does automatically, it turns any resource into a CDI bean, so you can use injection automatically. In Jakarta EE standard, you would have to and replace this stateless with something else, like application scope or request scope, or enable dependency injection for every class. So that's why I don't need to replace it. I can just remove it. If I really want to replace it with something that is equivalent, I would also have to turn on transactions with transaction orientation, because EJBs automatically create transactions. So if I really want to have the same semantics, I would have to replace it still also in Quarkus. But the rest is completely the same. And there's big chance that a lot of your code can be just started with Quarkus without any change. Or if you use EJBs, you would turn them into the CDI beans and add transactional annotation to behave the same way. Minimal changes. The only difference is how you package the application or how you set up the project. So the POM is it has some. Oh no, this is not the Quarkus one. Or is it? The Quarkus one. It has some specific configuration for Quarkus. It has the components from Quarkus. It has POM BOM or Quarkus BOM, and it also needs a plugin from Quarkus, which assembles everything together, does a lot of optimizations during build time, so that you have really fast startup times and a lot of things are prepared when you start the application. So build time takes a little longer, but then every start is a bit shorter. And on top of that, Quarkus has very good support for native compilations. It's the best support that I've ever seen, because the only thing you need is to turn on profile, or you set a system property in POM.xml, and that's it. It could fail if you don't have Docker. So ideally you have Docker, and in that case, if you don't have a GraalVM installed on your system, Quarkus will automatically pull a Docker image, run, which contains the GraalVM compiler. It will compile natively in this Docker image, and we will copy the output into the target directory, and you have the native binary without doing anything. You just need Docker installed, and Quarkus does everything for you. And alternative is to download GraalVM and then point Quarkus to the GraalVM compiler, and it will do the same, just on your machine natively, not in Docker. But it's basically just one, really one option. You just run Quarkus build with the native profile. And you have a lot of extensions. The community is huge. It has very nice development profile, which automatically redeploys everything, and it doesn't need to have the ID or anything in the background to automatically build your project. Quarkus detects all the source code changes. It runs the compiler to compile everything and updates the application. And what is also nice is you see it immediately, because when you access the application and Quarkus checks if there is something to compile, if there are changes in your application, and it will pause loading of your page while it replaces and redeploys the application, and then the page loads with the new changes, which is kind of different to what we are used to usually. That when you load the page too quickly, and the framework or the IDE doesn't have enough time to update the application, you still see the old version, and then you have to hit reload a couple of times until it compiles and you see the new version. But Quarkus will pause loading the page, so you just reload once, and if you're too fast, you just have to wait until the page reloads, and first load already sees the new changes. So there are some nice nice perks in Quarkus. The disadvantage is the same as with Spring Boot. You have like more complicated setup of the projects. Each thing you need from Quarkus requires additional dependency for that. In both cases, in Spring Boot and Quarkus, there is a generator for Quarkus. It's called Quarkus.io, where you can select which components you want, and you can download the zip file with the POM.xml that you can copy into your project. Same with Start Spring.io. It's the same. But there's also Start Jakarta EE, which kind of helps, at least in a bit, with the same thing for Jakarta EE. The main difference is that with Jakarta EE there's not really much to generate, because Jakarta EE provides one big interface jar, or even interface dependency. So if I go to the Jakarta setup, this is more complicated because it brings prime faces and a lot of test code. But where is the Jakarta dependency? Yeah, here. This is the only dependency that you need in Jakarta EE projects. And then you need the runtime, the GlassFish or GlassFish embedded, or even Quarkus, but Quarkus doesn't provide all of these. So with Jakarta EE, it's a different attitude. Like, you can build easily, but then to run, you need to provide a runtime, or you need to build at build time. You need to package your application with the runtime. What exactly SpringBoot does, and Quarkus too, we just don't see it. SpringBoot by default pulls in Tomcat and adds it to your application. But you can do the same with the application servers. You can do it with embedded GlassFish. A lot of other application servers can be bundled into your application, and then you have the same experience. You just create one jar that you can execute, and it starts the server and then your application on it. But yeah, so the starter for Jakarta EE basically generates this, and if you select one of the supported runtimes, yeah, here you can select the versions and Java versions, but it's really just properties. And then if you select, I need to select Jakarta E10, I think. You have runtimes which already support Jakarta E10, and I don't know why. GlassFish is not there. Okay, yeah, profile, web profile. Okay, so here's full Jakarta E10. You have these which officially supported now and are in the starter. There might be more, but they're not in the starter generator. And if you select these, they will add specific configuration so that you can start the server from POM, and you don't need anything, you don't need to install it. So your build will pull one of these servers, and then if you execute, I think, some profile, then you can start your application with the chosen runtime. So that's the value of the starter to tune for running. But if you want just to build, you just have the API package, and that's it. And then you deploy it on some server. So another alternative, I already mentioned Helidon. I don't know Helidon so much, so I'm not going to present it. But Helidon would be another alternative similar to Quarkus, supports native compilation, and it's from Oracle. Another alternative that a team or my company is involved in is an effort to build a new servlet container, very minimalistic but efficient, and contains all the power of servlet specification. And then build components on top of it, mostly taken from GlassFish or even in some custom components, to assemble a runtime that really has only the essential things, nothing from application servers like clustering or remote DJBs, but just what normally microservices would need. And you can start it. The benefit is that, especially for the servlet container, the startup time is even faster than the Quarkus, which is optimized, does build time processing. Piranha doesn't do anything from that. So for big applications, it would probably still have longer startup times. But for small applications, it can start in 200 milliseconds, while Quarkus starts in 1 second. And it proves that the problem is not Java itself. Java can start very fast. The problem is the frameworks that help us creating the application. It's very nice for us as developers, but the end result has some penalty because the framework needs to initialize things, and it takes some time in the beginning. And Piranha has another perk that you can very easily embed it into your code. It has a clear API where you can configure the whole servlet container, practically the same thing that you can configure via WebXML. XML, still around sometimes, but Piranha doesn't need that. You can set all the configuration using the API, and you can even invoke Piranha from your code. You don't need to have HTTP listener that's listening to incoming requests from a browser or from some client service. You can embed it and run it in your application, which is perfect for serverless deployments, where, as I mentioned, the cloud just invokes a method and expects some result. So there, you don't need HTTP. You can just initialize Piranha container, create a request object based on what's coming from the cloud provider, run it. It runs a servlet, runs the whole application, processes the request, even connects to database, outputs some response, and then the response is again an object that can be translated to anything. It can be translated to JSON. You can save it to a database. You can send it as an output for further processing. Thanks. So to conclude, there are multiple migration paths for you. My mission here was to educate you on all the options, not only what you can maybe find on the internet or what you think about. Obviously, SpringBoot is a good option. A lot of people like it, a lot of people use it. So if you prefer to stay with SpringBoot for a long time and switch to it, that's okay. But if you have already a lot of code base, adding SpringBoot to it doesn't mean that this code base written in Java EE would disappear. You would suddenly have to support both code bases, which are based on different frameworks. And other options, you have some other options which are closer to SpringBoot in terms of productivity and modern support for modern solutions, but still are very similar to the Java EE servers in the API. So you don't have to rewrite everything. You don't have to learn new stuff, new APIs. You can reuse your own knowledge of Java EE, and if your team is used to this, you can save time learning Spring Boot and experimenting with it. Just go with what you already know. So that's it. I don't know if you have any further questions. Are there some questions? So the question is, any words to Tomcat? Yes, if I had bigger time slot, I would also mention Tomcat. I have it on some of my slides, but I had to drop it. The thing about Tomcat is it's very small, and Spring Boot contains Tomcat. It can also use some other servlet containers, but Tomcat is not an application server. It's when you see like reports of popular application servers, it often appears there. But Tomcat is very small, offers small functionality compared to application servers. With Tomcat, if you want to redeploy an application, you basically need to restart. So you copy an application to some directory, but you have to restart. You don't have a management console or some commands to automatically redeploy the application or deploy a new application to it. It only provides servlet API. So with Spring Boot, Spring provides everything that is missing in Tomcat. That's why you don't need any application server. But if you have some other framework that doesn't provide all the functionality that Spring Boot provides, or Jakarta EE provides, you still have to add some components to Tomcat to be able to use this functionality. And then it takes time to assemble everything together and tune it so that different components work well together. But to say nice words about Tomcat, I tried to deploy a small application, and it's quite fast. I was surprised because I thought that Spring Boot, when I compared it to Jakarta EE applications, started in 2 or 3 seconds. But when I started just plain Tomcat, without all the Spring initialization, it started in 600 milliseconds. So Piranha is still faster, about 3 times faster, but Tomcat is still around half a second. And then you can see that Spring Boot is quite slower than Tomcat, but it provides all this functionality. And application servers provide a lot more functionality than Tomcat. That's why they start a little bit slower and consume a little more memory, but it pays off in the productivity. Because with Tomcats, yeah, you really can either write simple applications based on JSP or spend a lot of time assembling everything together so that you can use Tomcat. And then it's better to use SpringBoot or something else that has everything integrated together. Oh, okay, so more questions. Thank you for that. Any thoughts about Spring owned by Broadcom and Jakarta owned by Eclipse Foundation? Yes, a lot of thoughts and also a lot of questions. There is a fundamental difference between this ownership. In Broadcom is a commercial company. It can decide it is no longer interested in Spring, it will stop Spring. It can be sold, although Broadcom itself is quite big enough that probably nobody is going to buy the whole Broadcom. But Broadcom can sell Spring team to somebody else and like do whatever with it once we want to with it. Or it can keep it, but then it's them who govern it. So if they decide to reduce the team that spends time with developing Spring Boot, then yeah, it slows down the evolution. If they decide to change the license, what happened with like MongoDB and other examples, they can do that. In Eclipse Foundation, the ownership is different. They own the trademark. They don't own the source code because the source code is still owned by the contributors. So they can't change the license. They would have to ask all the contributors to accept the change of the license. And they just have the trademark of Jakarta EE or GlassFish or all these projects. And that's good because no other commercial company can block development, can say like, no, you cannot use the trademark. Eclipse allows using the trademark. It has to be protected, but you can use it, you can develop it. You just cannot create a fork on yourself and call it Jakarta EE, because that's how Eclipse protects it. But anybody is free to join. It's clear, it's transparent how you can join the Jakarta EE working group, how you can join individual projects. If there's not enough involvement, anybody can say like, I want to be part of it because things are not moving, let me in and I will try to participate more and move it forward. So it's an open collaboration compared to Broadcom, which still is just one company that owns Spring. If you want to contribute, they have to accept it, and there's nobody else that would have a word in it. So that's the difference. But we could talk later about my thoughts. I think I don't have time for more questions or answers. So thank you very much, and enjoy the rest of the conference.